Now let me come to the point of spherical capacitors. Okay, so in spherical capacitor, there are two situations. In first situation 1, we are considering two concentric spherical shells. Okay, I'll consider the radius to be A and B. Okay, a charge of Q is given to the inner sphere. A charge of Q is given to the inner sphere, and the outer sphere is grounded. Let us see what will happen in this situation. Okay, so when the outer sphere is grounded, we understand in the outer sphere a charge of minus Q will get developed. These points in Gauss's theorem and all we have already discussed grounding. Right? So we need to find the capacitance of the system. How to find the capacitance in the system? So if you have to find capacitance of the system, we have different ways. Out of that one, I'll explain the very simple one. That we have to find the potential difference between these two surfaces. We have to find the potential difference between these two surfaces. Okay. So potential of the inner sphere, inner surface. Potential at inner surface. Let me call the inner surface to be A and the outer surface to be B. Potential at the inner surface VA. How much is the potential at the inner surface? Potential at the inner surface is nothing but the potential due to its own charge. What is the charge on the surface? Q. So because of its own charge, how much will be the potential? K. Q divided by A. Plus, here there will be one more potential. That potential will be because of the outer charge. For the outer charge, this particular point is inside it. We know if there is a sphere having charge Q and a radius B. Okay, so for this particular charge, within potential will be same as on its surface, that is K minus Q divided by B. So that is why at this particular surface A, there will be the potential because of its own charge will become KQ by A, and because of the outer charge will become how much? K minus Q by B. So this is the potential on the inner surface, right? Similarly, potential at the outer surface. Potential at the outer surface. Let me call the outer surface is VB. So how much will VB? Potential at the outer surface is one potential will be because of its own charge. How much is that? Minus KQ by B. And another potential will be because of the charge which is present inside. Okay. So the charge on the inner sphere is how much? Q. Radius of the inner sphere is A. Where we have to find potential on the outer surface. On the outer surface, what is the distance? Distance is B. So that is because of the charge at a distance B, potential will become KQ by B. Okay, so the potential on the outer surface because of the inner charge will become KQ divided by B. This is the potential at the outer surface. Potential at the outer surface. How much is that? Equal to 0. Okay. Or we could have said it directly also, since the outer sphere is grounded, so potential will become 0. So this is the potential at the outer surface is 0. So what is the potential difference between the two surfaces? So potential difference VA minus VB is nothing but equal to VA. And how much is that? Let me take KQ common. If I take KQ common, it will left out with 1 by A minus 1 by B. This is the potential difference between both the surfaces. Okay, so this one we can write it as Q divided by 4 pi epsilon naught. If I take AB LCM, B minus A. This is the potential difference VA minus BB. So therefore, the capacitance of this system, C, capacitance is what? Charge divided by potential difference. How much will become? This will become 4 pi epsilon naught AB divided by B minus A. This is the capacitance of this system. Two spheres, when the outer sphere is grounded, okay, this will become the capacitance. Okay, Let me show you one more method to find capacitance using the concept of electric field. Let me consider a point here at a distance r. If I can, okay, at this particular point, what is the electric field? Definitely electric field will become outward, because at this point electric field will be only because of the inner charge. For the outer charge there will be no electric field out here. Okay, so electric field at this particular point will be given by electric field. How much is that? K Q by R square, or we can write it as Q divided by 4 pi epsilon naught R square. Q divided by 4 pi epsilon naught R square. Now let us find out potential difference between the two surfaces A and B. How will we find a potential difference? Delta V. Delta V means what? VB minus VA is nothing but equal to integration minus integration E bar dot dr bar. This is also we have discussed already in electric potential. So potential difference is nothing but, okay, integration E bar dot dr bar, and we want to find out the potential difference between the surfaces A and B. So now the direction of electric field is outward, and direction of R is also outward. So E bar dot dr bar is equal to EDR. We can write it as E bar dot dr bar is equal to EDR. And how much is E? How much is EQ divided by 4 pi epsilon naught? I can take it out. dr divided by R square, and R is going from A to B. We want potential difference between this surface and this surface. So here R is A and here R is B. So how much we'll get from there? VB minus VA is equal to minus Q divided by 4 pi epsilon naught. Integration 1 by R square is minus 1 by R A to B. VB minus VA. Let me take out the minus sign. Minus will become plus Q divided by 4 pi epsilon naught, or I can use it as okay, fine, I can keep the minus sign here. 1 by A minus 1 by B. 1 by A, because of the minus sign I'm putting the lower limit first and the upper limit. Okay, fine, this part you know it. So minus Q divided by 4 pi epsilon naught AB B minus A, which implies VA minus VB is equal to Q divided by 4 pi epsilon naught B minus A divided by AB. Okay, I've just reversed it and minus sign disappears. So therefore capacitance is nothing but Q divided by VA minus VB. So how much that will give us? 4 pi epsilon naught AB divided by B minus A. This is how we can also find the capacitance of the system using the idea of electric field. Okay, note it down. Now in the second situation, right, a charge of Q is given to the outer sphere. Okay, so if a charge Q is given to the outer sphere, how much charge will get induced in the inner sphere? Can you tell? Okay, because of this particular charge there is no electric field inside, so inside there will be no induced charge. Okay, So for that, what will happen, because inside everywhere potential is uniform, but if you ground this sphere, inner sphere, if you ground it, then the induced charge will get developed inside. How much induced charge will get developed? Let me call that induced charge is equal to Q dash. Okay, and how much is Q dash? We have already done it. How much is Q dash? Minus A by B into Q. How much is Q dash? Minus A by B into Q. We have done that in Gauss's theorem. I hope so. Otherwise, if you do not remember, I'm showing it to you. If you do not remember, I'm showing it to you. How to show it? This is the surface A. This is the surface B. This is the surface A. This is the surface B. Surface A is grounded. Surface A is grounded. Okay. So therefore, net potential at A will have to be equal to 0. At A, net potential will have to be 0. Okay. At A, there will be one potential because of its own induced charge. How much is that? K Q dash by A. And the other potential will be because of the outer charge. Okay. Because of the outer charge, potential at this point will become how much? Same as on its surface. Because of the outer charge, potential inside is same as on its surface, KQ by B. Okay. So potential, the other KQ by B is equal to 0. So from here you get Q dash, KK cancels, Q dash is equal to minus A by B into Q. This is the induced charge on the inner surface, that is Q dash. Okay. Okay. Now, what is the potential on the outer surface? Potential on outer surface, VV. Potential on outer surface. Here there will be two potential, one because of the inner charge, one because of its own charge. Because of its own charge, KQ by B. Because of the inner charge, KQ dash by B. KQ dash by B. So if I take K Q by B, and this will become K by B. Q dash is how much? Minus A by B into Q. So this minus, I'm making it minus. Okay. K is there. Q A by B will make it B squared. So from here we can take KQ common. Within bracket what will remain? B square. B square is LCM. 1B will remain here. 1A will remain there. This is the potential on the outer surface VB. Okay. So therefore, capacitance of the system. How to calculate capacitance of the system? Therefore, capacitance of the system, charge divided by potential difference. How much is potential difference? VB minus VA. Okay. This is positive potential. This is zero potential. Q divided by VB minus VA. So from there, how much will be getting? Q divided by VB. VA is equal to 0. So it is 4 pi epsilon naught B square divided by B minus A. Now, how to find capacitance using the idea of electric field, as has been discussed in the previous case. Okay. So for it, what you do? You consider a point here. At this point, you find out the electric field. Electric field will be inside. Why? Because this Q dash is negative. Because of the outer charge, there will be no field here. Because of the inner charge, electric field will become towards it because this is negative. So therefore, electric field at that particular point will become Q dash divided by 4 pi epsilon naught R square. Q dash divided by 4 pi epsilon naught R square. Okay. So how much is Q dash? I'm already putting the direction in that sense. Okay. So I'll not be using the minus sign again. So this is Q by 4 pi epsilon naught to B R, and there is a A. So therefore, potential difference between the two surfaces, minus integrations E bar dot dr bar. Okay, potential difference between the two surfaces. Okay, and the direction of r is from inside to outside, so that is why potential difference means Vb minus Va minus, so E bar dot dr bar, r bar is outward, E bar is inward, so their dot product is negative, so minus and minus will make it finally plus. Okay, integration E dr going from A to B. So let me put the limit in the next line. How much is that? QA divided by 4 pi epsilon naught B dr by, this is r square going from A to B, going from A to B. So Vb minus Va is equal to QA 4 pi epsilon naught B minus 1 by r A to B. How much will be getting from here? QA divided by 4 pi epsilon naught B, and that will become 1 by A minus 1 by B, and this will become, if we take LCM, AB, and this will become B minus A. So one of the getting cancels. Q by 4 pi epsilon naught B square B minus A. Therefore, capacitance is Q divided by Vb minus Va. How much you will left out with? 4 pi epsilon naught B square divided by B minus A. This is the capacitance. So these are the two situations we have seen in case of spherical capacitor. Situation 1, a charge of Q is given to the inner sphere, outer sphere is grounded. And situation 2, this is the one, a charge Q is given to the outer sphere and inner sphere is grounded. Okay, so now it is a cylindrical capacitor. For that we have considered two cylinders. One is in the inner cylinder and the outer cylinder. Here A is the radius of the inner cylinder and B is the radius of the outer cylinder, and L is the length of each cylinder. Capital L, we are using capital L to be the length of each cylinder. Okay. A charge Q is given to the inner cylinder and outer cylinder is grounded. So on the outer cylinder, a charge of minus Q will get developed. Okay. Right. So to find capacitance of the system, what we will do, we will consider a Gaussian surface. And to find potential difference between these two cylinders, so for that we'll have to find out electric field in the region in between. Okay. So for that, what we'll be doing, we'll consider a Gaussian surface. Gaussian surface having radius r and length small l. Now that is the Gaussian surface. Now let us apply Gauss's theorem. So applying Gauss's theorem, okay, the flux associated with this Gaussian surface, how much will become the flux associated with this Gaussian surface? Q will become, the flux associated with this Gaussian surface, phi will become, the flux associated with that Gaussian surface, phi, will become equal to total charge enclosed by epsilon naught, 1 by epsilon naught, total charge enclosed. What is the total charge enclosed? Total charge present on the inner cylinder is Q. Q is present over a length of L. So this particular surface means within this, from this particular point till this particular point, this particular length is how much? L. So within that length L, how much charge will be there? Okay, when the length is L, a charge of Q remains. If you think about unitary method, okay, because charge is uniformly distributed, And for a length of L, charge will become Q by L into L. So that will become Q small l by capital L. So flux will become nothing but integrations E bar dot ds bar QL divided by epsilon naught L. Okay. So E bar dot ds bar, how much is E? Okay. Electric field is normal to the surfaces. Electric field is normal to the surfaces. So E bar dot ds bar is EDS only. E will be coming out, and integration of our ds cylindrical surface, because cylindrical it has got two surfaces. One is plane surface, two plane surfaces, and there is a curved cylindrical surface. Okay. Lines of force will be going out perpendicular to the cylindrical surface, but it will become parallel to the plane surface. So flux associated with bodies to the plane surfaces will become zero, and whatever bit of flux that will get associated, that will be associated with the cylindrical surface only. So that is why cylindrical surface is nothing but twice pi r into L. So that is Q L divided by epsilon naught capital L. So from here we get the electric field Q divided by twice pi epsilon naught L into R. From here we can find out the potential difference between the two surfaces. So potential difference between both the surfaces, potential difference between both the cylinders, delta V will become integrations E bar dot dr bar. Okay, E bar is also outside, dr bar is also outside, so E bar dot dr bar is equal to EdR only. How much is the value of E? Minus Q divided by twice pi epsilon naught L, till here it is constant, R is a variable, integrations dr by R. Value of R is going from A to B. So this potential difference, that is what? Vv minus Va. If I call the inner surface is A, outer surface is B. Vv minus Va. So this can be written as Va minus Vv, because potential of the outer surface will become 0. That will become Q divided by twice pi epsilon naught L. Integration dr by R is equal to integration dr by R going from A to B. How much will become? Ln R A to B. How much will become? Ln B minus Ln A. So this will become Ln B by A. So log B by A. Therefore, capacitance of this system is Q divided by Va minus Vv. How much will become? Twice pi epsilon naught L divided by B. This is the capacitance of a cylindrical capacitor.